sharing the architecture and content of a FinOps Data Lake to enable advanced BI. Please welcome Lóránt Kiss.
Thank you so much. Thank you. Thank you so much. It's great to have you here, actually. As Joe mentioned, my name is... Let's go another one, yeah? Let's go another one. Yeah! Exactly, that's what I want. All right, we will be running out of time, so. Okay, so my name is Lóránt Kiss, and I am the FinOps Engineering Manager of Amadeus. And actually, today I brought you a presentation about our data lake, an analytical solution that we've built. I'm going to talk about the architecture of it, the content of the lake, as well as I'm going to show you a number of screenshots from our reporting. Before that, however, I want to introduce a bit our company, because it's business to business. You might not know who Amadeus is. So who of you have actually flown in to attend the event by a plane? Okay, quite many people. So rest assured that behind the services, Amadeus has been helping you for buying your ticket, for checking in your luggage, or boarding the aircraft. We are actually in the travel domain. 500 airlines are our close to 500 airlines are our customers, but also ground handlers. Also, more than 1 million hotel properties are managed through Amadeus systems. To make this happen, we are actually historically using a data center in Germany, which processes 1 million business transactions per second. Actually, in my previous role, I was manager for SRE, managing 120,000 transactions per second. It's a pretty awesome component. And in this data center, we have tens of thousands of physical and virtual machines. And we set off on a cloud journey in 2017 to move to the public cloud. And as the cloud enablement started, actually in 2018, we built ACS, Amadeus Cloud Services, which is our internal Kubernetes-based containerization platform. In 2020, actually, we launched our FinOps operation. In 21, we went into a strategic partnership with Microsoft. However, we are still a multi-cloud provider business. We have quite a footprint still in AWS and GCP, so it's not exclusive. And in 2022, actually, we released just about a year ago the system that I'm going to show you. Now we are entering the adoption phase, as well as the mass migration. I will start actually with a key takeaway from our previous talk. You actually can have a look at it on YouTube. It's from the April summit. And in this presentation, we explained a little bit the thinking about our FinOps. And one thing I would like to point out here that often people ask the question whether to build or to buy something. In my view, this is probably the wrong question. It's more analyzing what you need, what are the components you want to do, and more ask the question what to build and what to buy. So in our case, because we had some special requirements about cost allocation or distributed forecasting, this component, the data component and the reporting component, we have actually built ourselves. So let's move on to the architecture of this. And this is a little bit more than the lake. It's the complete analytical solution, and treat this as a snapshot. Every architecture is evolving. The data here travels actually from the left to the right. You see that the data sources, obviously the bill is one of the biggest ones, but you will see we have lots of other data entering the lake. So this goes into an Azure Data Lake Storage Generation 2. Mostly the data is stored in CSV as well as Parquet format. And we are processing this with serverless technology, Azure Functions. Also the orchestration layer on top is Azure Functions, durable functions as they call it. And then the right two boxes are really for serving up the data. The Synapse SQL serverless is actually not storing anything. It's really there to provide you an SQL interface to reading your data in the lake. And eventually the data travels into an in-memory database or data set in Power BI, which enables you really fast reporting. And Power BI is also the platform that we use to build up the reports, dashboards, and put it into a navigatable application. So let's zoom on a little bit on this lake. What are some key facts and figures? So we have about 100 containers, 100 different schemas in this data lake. Schema actually means one sort of a table or one sort of a hierarchical structure. Today, we have 250,000 files, or binary long objects, blobs, in this data lake, which occupy 7 terabytes of storage. Again, we are before the mass migration, so you can expect that this data will actually grow quite a lot. We are targeting a 37 months active retention. Those of you who deal with machine learning, trying to forecast, infer patterns from time series know that 1 year of retention will not do it because you need to have multiple years to understand the patterns over the year. The next two numbers, compression ratios 1 to 10 and 1 to 5. This is how much you can save if you actually store your data, for example, in Parquet format instead of CSV. This is a 90% save in our experience. And if you compress your data from a daily to a monthly, this is giving you a 1 to 5 in our experience. One would expect that probably it's 1 to 30. It's not, because you have a lot of dimensions you aggregate with it. And actually, with this, you go into much more rows. So a 1 to 5 is, in our experience, what's working. Last but not least, the 7 is actually our number of our SLO metrics. We really act like an SRE or DevOps team. And we defined availability as well as 6 other metrics, mostly for data quality, like completeness or freshness of the data, to track for ourselves. So how does the data get into the lake? The data enters 3 ways. Either, very simply, you go to the cloud provider portal, you enter some configuration, you put your target location, and the data will appear automatically. This is typical for the bills. Then we have data that we actually pull for ourselves. We operate the code to reach out either internally or externally to the internet, to documents, to APIs, and take snapshots. Typically, we take daily snapshots so that we have a historical understanding of this. And last but not least, we have cases when we really just provide the container, we set up the right permissions for another team, and it's up to them to push the data to us. This is our case, for example, for cost allocation keys. I wanted to also tell you about 6 thoughts or things it's interesting to think about when you build a data lake. We talked already about the containers. So the separation on a schema layer is interesting because you want to be both secure and you don't want to go into a mess. So I think separating it not just on, so to say, folder level, but container level is a good practice. Second point, partitioning. Typically, you don't want huge data in one monolith, so you partition it. Our partitioning scheme is time-based, so we have years, months as folders, and typically the files are separated day by day. But you can use other dimensions for partitioning. It will happen to you that the provider of the data will change the name of the column, your pipeline breaks, so you need to prepare for versioning it. In fact, in one container, we have multiple versions of the same data as it evolves over time, and then you can control it also from your code. Storage. For storage, the shape of the FinOps data or the usage of the FinOps data is like you put it in the lake, you write it once, you don't really modify it, but then you query it a million times and you keep it quite long. So for this shape of data, based on today's best wisdom, you use a columnar store, which is compressed, such as the Parquet format, but there are also alternatives. Semantics. For semantics, it's to say that when you have a cryptic name of a column and you want to expose it to your business users, not sure they will understand in controlling or in product management what the engineers meant by a cryptic name. So it's always interesting to think about the end user in mind, and also later on natural language processing to have meaningful names for your columns from the start. And last but not least, a data mesh strategy. Amadeus has a data mesh strategy, and I consider FinOps as a target for FinOps to be one of the nodes in this data mesh so that the business teams can actually use the data to mix it with their own. All right, let's go a little bit into what's in the lake, because I think it would bore you to hell to have 100 containers, one by one, going through the slides. I did a bit of grouping of them. Looking at the grid on the top with these 4 items, I used actually 2 dimensions. One of them, whether the data is of internal source, so from Amadeus, or from external source. The other is whether the data is basic or really more beyond the obvious. That's what I called advanced here. And last but not least, the fifth part on the bottom is really operational data, which is, so to say, generated in and from the lake itself. So let's start by the external and obvious. You will want to put your cloud provider bills into the data lake. If you're multi-provider, you want to put them as well. For those of you who are operating, for example, multiple enrollments in Azure, you probably want to separate them into different containers, as well as you want to do amortize and actual data download separately. We do post-process these bills. We have derived augmented products, what we call the curated bills. So after cleaning and enrichment, we actually put that into a new container. I'm really looking forward for Focus to solve much of our problems here, actually. And we also do cost allocation mechanism, and furthermore, an expanded cost to be able to drill down into the allocation. Now, what's beyond the obvious? And these sources are all from the provider or from the open internet. Orphaned resources. This provides you a savings opportunity that is not obviously appearing in the cloud provider recommendations or in the bill itself. I just saw a presentation from Adobe. It was great to see that they managed to even automate this and achieve tremendous savings. For us, actually, we are reaching out to 4 different APIs and identified, for example, the allocated VMs on attached disks as orphaned resources, and we pull them into the data lake. Obvious thing is probably the cloud provider recommendations, but be sure to make your own calculations, because what we found is that often they are not considering some of your discounts, and it's interesting to see the actual potential and not be mistaken. Utilization. Your engineers will be super interested in the utilization. For example, for VMs, you could imagine both the CPU and the memory utilization and its evolution over time to understand what are the shapes of the workloads and do optimization beyond the recommendations. Sustainability. Cloud providers now provide CO2 data. Typically, it's not granular enough. We actually use our cost allocation process to attribute it to the different services. Commitment-based discounts, both the transactions of reserved instances, savings plans, committed use discounts, as well as the recommendations is interesting to pull together so that you can model financially better. CSP metadata, I mean, I pulled Azure examples here. As I mentioned, we are a Microsoft partner, and for this reason, we are also heavily investing into Azure. So in their case, for example, for the flexibility of reservations, they provide this very cryptic name, tables instance size flexibility group and AutoFit combo meter. If you're in Azure, you might want to look into these. And last but not least, pricing. Your price sheet and public price list will help you to understand, so to say, the street price versus what you're getting at the end, and maybe even drill down into the details of your discounts, whether it's from the reservations, whether it's from foreign exchange rate gains or whatsoever. Let's focus internally now. In Amadeus, actually, the language that our people speak revolves around the first 2 boxes here, products and services. Product is, for example, the Altea suite, which we offer to airlines. And this is a term that's very familiar to marketing people, to product managers. Underneath, you have multiple services, like in our case, customer management to board your aircraft, or flight management to depart your aircraft and check your luggage, which are more technical applications. This is what we call services here. And underneath, you even have teams which serve these applications with a database or with containerization environments. So all of this is cataloged in Amadeus in separate systems, and this is something we are also snapshotting on a daily basis. And this forms key dimension for the reporting, so that everybody understands the language. Foreign exchange rates. As we are building multiple currencies, sometimes US dollars, sometimes euros, you want to make sure that your controlling team, finance team, is aligned in the way you're converting those currencies, and you can report both ways. Zoning. Zoning is actually a concept that we internally developed to encourage or discourage the use of certain types of resources. We do this, for example, for VM families as well as different regions because of it could be the price, it could be the life cycle of the product. We might prefer or not prefer certain types. We use here green, amber, red, black categories, and this is also evolving over time. And the last two, just to mention, it's more a bit of metadata or configuration data to manage your systems. Can be groupings of things, can be whitelists. For example, if you're doing tag processing and your organization uses thousands of tags, but in FinOps you're interested only in 100, probably you want to whitelist them and work only with that part of the data. Okay, the more advanced or specific to us is that we are asking our service teams and application teams to provide us data about how they are used. For example, if there is a database team which is used by many business applications, we ask the database team to provide us cost allocation keys, meter the usage of their customers internally just like you would be a provider. And from products, we also ask for North Star metrics. For example, in our case, passengers boarded or flights departed can be a very good North Star metric. One highlight case here is the PaaS, so our containerization platform on Kubernetes OpenShift. Here we really rely quite a lot on Prometheus monitoring data or observability data for 3 use cases. To understand how much people requested and compare to that how much they used. To make sure that the cost allocation is also fair and based on this data, and also to correct the labels that they are using in the PaaS. And last but not least, the operational part. The top one, the direct one, is really data that the report consumers use or the data set consumers use. These can be for performance reasons, pre-aggregation, pre-calculation, or, for example, detection of anomalies and the logs of their notifications. The supporting data is more for our FinOps engineering team, so that to understand what are the container sizes in the lake, how does the data look like, for example, grade expectations, data validation results, test results, because we are also looking end-to-end to the system, so we are testing the UI, or anomaly detection metadata or other configurations. All right, so we get to the point of the showcase a few reports. This one is actually a cost breakdown for an internal service. So you could imagine you're in an engineering team which operates a database or operates our customer management. You can come to this piece of the report. You can see actually on the top you have different personas. So we are in the engineering persona, and we are looking at cost by provider. But what we mean by provider here is not just the cloud provider. But as mentioned, we do the all locations. So if your customer management application and you're using a database underneath or containerization, you will see the breakdown of this data. It's kind of your internal bill. On the bottom, you see actually different breakdowns. The 4 we are mostly using are instances of the service, environment of the service, architectural components, as well as partitions if the application happens to be partitioned for high availability or compliance reasons. One interesting feature actually that comes with the Power BI platform is the ability to explain an increase or decrease. For this to work, obviously your data has to be in a specific shape. But what you can do, as you see this timeline on the line chart, there was a big increase. Right-clicking on the top data point, you will get suggestions or ideas the system identifies as most likely to contribute to this increase. And in this case, I could see in this list which environment in production and which component, it happens to be a Redis component, that was causing this increase. So it saves you some time by not having to drill for yourself and try to search for the reasons. I'm not saying it always works, but it oftentimes gives some good idea. Unit cost related capabilities. So here we are mixing the organizational metadata, the service and instance data with the cost allocation and the bill itself. So you see actually on the top left the evolution of the unit cost. Below that you see the total cost and the total volume, so just the numbers you calculate the unit cost from. And the interesting bit is actually the bubble chart. The bubble chart shows the instances. For example, if there's a database team, it shows the instances of the database, different clusters that are served to other applications. And this chart can be used to identify, first of all, the economies of scale, because you would expect the higher the volume, the lower the unit cost. So it should show up on the chart accordingly, and it helps you also to identify outliers like the big red bubble, which is an instance which is both high in volume and high in unit cost. So you might want to look into that and compare it to the blue ones below, because they are pretty low unit cost and probably they are doing something better than the others. The mentioned cost avoidance orphan resources. So here, pulling the data from different APIs, we can, for a service team, identify the savings opportunities of these 4 categories that you see on the screen. So the VMs, the storage, snapshots, and IPs. And we also have on the bottom table the capability to drill down, and then a direct link actually to the cloud provider portal. So if you want to take action, you can directly go there. VM zoning, this is the mentioned zoning concept. Here I actually filtered this report for 3 different database technology teams. That's what you see on the top bar chart, and you can see that the biggest spender team is quite doing well because they have a lot of footprint in the recommended green zone, whereas the second one is really falling behind with the amber and red, so something needs to happen there. Of course, there are drill down capabilities into this. And last but not least, a little bit more advanced or forward-looking capabilities. Actually, we use cognitive services to detect anomalies. How we do this is that we, by service, supply the daily total cost, the allocated cost to the system. For each service, there is a model built. I mean, the model, very simply, you can see the thicker blue line in the middle with the top and bottom margins on the side. And if you're within this range, within this tunnel, you're good. If you're going outside, like the big spike there, we are able to send a notification to the team. Something needs to be looked at. The bar chart one, the horizontal bar chart one, is more experimental, but it's kind of forward-looking to ask natural language question, and the system generates for you the proper visuals or gives you the proper number. This is not something ready for production, but we are experimenting with it, and this, I mean, I would refer back here to the semantics, because it's interesting how people will ask this question and how the system will understand it. But it's a good exercise, and I think for the future it's interesting to prepare with that. All right, I'm ready to wrap up. So key takeaways here. There is really a lot more to FinOps data than just the bill. So I think it's interesting to pool together your data assets. I think FinOps can be a game changer and even go beyond FinOps, go to financials. Second point, I personally believe, is that modern day analytics and BI tooling makes it easier than ever before. Don't be mistaken, I'm not saying this is child's play, but it's possible. And if you're pulling together a few engineers with today's technology, you can handle quite large data sets meaningfully. And one more thing, it's more referring back to the April summit and our cost allocation code, which we actually open sourced. So feel free to look at the video and also just simply type Amadeus FinOps in the browser search bar, and you will have on the first page results both the video and the cost allocation keys. And I think that wraps it up.
We have a little time. Are you okay with questions?
Yeah, we can go for questions.
Anyway, all right, I like it right here.
Hello, great presentation.
Thank you so much.
I had 2 questions. One, what's your retention period for the data that you do keep and store in the data lake for all cloud costs? And then 2, funny story. Data lake has actually been one of our top cost problems within the cloud. So did you get any pushback from executive leadership to use data lake as the tool to then reduce costs in the cloud?
Right, okay.
And if you did, what persuasion
So
metrics
the first
you used?
question, I mean, I mentioned this 37 months for active retention. That's to work with the data. But if you're asking, how long otherwise, I would say compliance, legal compliance, tax compliance should give the answer. I think it's in the range of 5 to 7 years, typically what's required, but people often keep it even longer. We don't have that long data. Even we don't reach the 37 months yet. Yeah, so it will evolve over time, but that's what we have in mind. For the other question, can you remind me? Pushback, okay, cost of the system and pushback. No, actually, my boss set me a concrete limit. Lóránt, you cannot spend more than this per month on this one. We set it in the tool, and we keep it. No, actually, you have to make your own calculation, but according to our calculation, it's worth the price, yeah.
Techie question, actually two, because she asked to. What do you use for the query engine, and how big's your team?
So, excuse me?
What do you use for the query engine? I'm assuming you're using Trino or something like that.
Okay, so,
yeah.
I mean, I would differentiate two use cases because we offer the reports for end users, and we offer the data set as well for more advanced people who want to build their own reporting. So data as a service kind of, or data as a product kind of thing. And actually, you can enter this on, I would say, 3 layers in this architecture. You can either directly use the lake data, which is for investigation, for very weird things like special character blocks the thing. You can enter on the Synapse layer. So if you're a data as a product user, you would enter to Synapse. Synapse is not storing anything. It provides an SQL interface. You create views just like you would on your traditional database, but it's on Parquet files, for example, and that's what you can use. Then when we talk about the in-memory part, so you have the Power BI data set, and for that you have Microsoft-specific DEX query language, more analytical language, where you can build measures and other stuff. So this is the 3 ways we could offer. I prefer we go from the right to the left, depending on the use case. So first, people really use the Power BI data set, and if it's not sufficient, then we go back.
And how many people on your team?
It's kind of a 1.5 pizza team. Well, the FinOps team altogether, I mean, in European terms, it's probably sizable. In American terms, it's not like this, let's say about 15 people. I don't know the exact count. Out of this, the engineering team is more like 6 core engineers, yeah, roughly. That's how I would put it.
I'm curious, what kind of tagging strategy have you implemented to help support this kind of reporting?
Sorry, can you speak up?
Can you talk about the tagging strategy that you've implemented to help support this kind of reporting?
Can you repeat me the question, Joe?
The tagging strategy.
Tagging strategy, okay. So, yeah, that's something we much earlier started with, and not FinOps alone. I mean, there was also a time when people called this FinOps tags. It's not FinOps tags, it's cloud tags, security equally interested, and several other groups, IT asset management whatsoever. So we actually tried to pull together these people and form the board. So we in that sense, we don't have this cloud center of excellence, but more an autonomous board from all the people who are interested, who actually put out a policy. And this policy is then checked against what we see in the cloud, and we track a KPI on the top level how people are doing this. What we haven't implemented yet, but I would find interesting, is to have a combination of tags and say whether this resource is FinOps compliantly tagged, because security is interested in another set of tags than us. It has an overlap, but it's not completely the same. And we could evaluate a resource as well tagged or not well tagged, not just looking at a single tag, and then present it to the users that way. That would be an interesting evolution.
That's awesome. That's about as much time as we have for questions. You can catch up with Lóránt on the aircraft carrier tonight. You could also go on FinOps.org to search for his previous talk that he referenced. Also on the YouTube page where you can find last year's FinOps X sessions and where we will upload these recorded sessions this year. So let's outdo Breakout Room A. It's Stacy Case over there, so we got to drown her out. Everyone, give a big round of applause for Lóránt.
Thank you.
Thanks for watching that session. I'm sitting here in San Diego right after FinOps X. We hope you join us next year here live 2024. In the meantime, please subscribe to the channel and join the community. Get involved, join the summits, get in a working group, and don't forget to get FinOps certified. Because next year here in San Diego for FinOps X, it's going to be twice as big. Come join the party. Come meet your people. Welcome home.